vlog series. Today we are covering bidirectional shift register. Firstly, shift register is a cascade connection of flip-flops. That means the first flip-flop output is connected to the next flip-flop input. So like this connection flows on. Coming to bidirectional shift registers are the storage devices capable of shifting the data either right or left depending on the mode selected. So this is the block diagram for bidirectional shift register. This is the example for 4-bit bidirectional shift register. The pin right or left bar decides whether the shift has to be left or right. And for all the flip-flops, we are giving synchronous clock. So this is the block diagram for n-bit bidirectional shift register. Initially, by using this clear pin, we clear all the registers, and then by using right or left bar pin, this is the control line. It decides whether the operation is to be left shift or right shift, and so on. So this is the n-bit shift register, and it is performed using n number of flip-flops. Each flip-flop stores 1 bit of data. So coming to truth table, in n-bit bidirectional shift register, it requires a number of clock cycles to perform n operations. So this is the main pin. Whenever this pin is high, it performs right shift. Whenever it goes low, it performs left shift. To clear the registers, we use this clear pin. Whenever the clear pin is high, it will clear all the registers. So here we clearly see that whenever this pin is high, for one clock cycle, it is shifting the data by 1. It will shift the data by 1. In second clock cycle, it is shifting the data another time. So on the operation goes. So this is the timing waveform for n-bit bidirectional shift register. Similarly, we have seen in truth table. This is also same. At every passage of clock, the operation performs. Whenever this pin is high, it performs right shift. Whenever this pin is low, it performs left shift. Whenever the clear signal is high, then all the registers get cleared. Yeah. So now let us see the Verilog code for n-bit bidirectional shift register and verify it using test bench. Module name, and then by using this parameter keyword, we can write n stages for n-bit bidirectional shift register. If you want to design 8-bit shift register, then we can simply write 8 in the place of 4. Parameters are the constants, they are not variables. So within the parentheses, we are declaring inputs and outputs. So DN clock are the inputs, and enable pin is used to switch the shift register to on or off, and the direction pin is used to shift the data either right or left side. And by using this always block, we can trigger the clock. At every passage of the clock, the data is get shifted or the data is get changed, and it will enter into the block. First, it will check whether the reset pin is 0 or not. If it is 0, then it will clear all the registers, or else it will enter into the next statement. Whenever the enable signal is high, then it will shift the data based on the direction pin, or else it will maintain the previous output. So whenever the direction pin is 0, it performs left shift. Whenever the direction is 1, it performs right shift. So this is the RTL code for n-bit bidirectional shift register. Coming to test bench, module name, and input and output arguments. Here we are instantiating the RTL code in the test bench. So here we are connecting the design with TB signals and then generating a clock of frequency 50 megahertz by using /10 nanoseconds. And within the initial begin and block, we are instantiating variables to default values at time is equal to 0. So making all variables as zeros. And here we are driving the stimulus. First of all, we are making reset pin as low. Here all the flip-flops get cleared, and then we are making reset pin and enable pin high. So after that, for 7 clock cycles repeatedly, we are driving the signals to data pin, and we are changing the direction for another clock 7 cycles. And then at last, we are monitoring the variables and print them in our log file. So this is the test bench code for n-bit bidirectional shift register. Let us simulate our code. Go to the model sim and this click create a project. Bidirectional shift register. Bidirectional shift register. Let us save our code in our desktop. So this is our code. Select folder. Click on OK. Add existing file. We have already written the code. Just we are adding. OK. Add our test bench code. OK. Compile. And let us check for the errors. So there are no errors. Tick mark is given. And let us simulate our code. Go to the work file and select TB file. Click on OK. Add wave. Run our code. So here we can see, so this is our data. This is the clock. At every passage of clock, the data is get changed. This is the enable pin. So this is our direction. Whenever it is low, it performs left. Whenever it is high, it performs right operation. And this is the reset pin. And this is the output we are getting. So we can see the same result in console window or transcript. So this is the output. Okay, thank you guys.